Hey guys, so today we're going to continue with section 1.6, inverse functions. So inverse functions, in order for a function to have an inverse, it needs to be one-to-one, meaning it's passing the vertical line test, which makes it a function, and passing a horizontal line test. So there are only one set of x's, and each y is unique as well to be one-to-one. So in order to show algebraically that two functions are inverses of each other, we can take the composition of functions. So think back to what we learned in the previous class. The composition f of g of x, if they are inverses, then that would mean that their composition equals x. This is our goal. So in this case here, f of g of x, that would mean f of the cube root of x plus 1 over 2, it's all under the cube root. So we are replacing x in our f of x with that whole thing. The cube root of x plus 1 over 2 cubed, because it's cubed here, times 2 minus 1. The cube root cubed, these two are inverses of each other. When you are raising a cube root to the third power, it's the same thing as raising a square root to the second power, so they go away. So you are left with x plus 1 over 2 times 2 minus 1. The 2's cancel here. So you are left with x plus 1 minus 1, which equals x. And that was our goal. So this, yes, in fact, f of x and g of x are inverses of each other. All right, which of the functions is the inverse of this f of x up here? Take a minute and find out which one is an inverse of f of x. So if you're trying to find if g of x is the inverse, you're going to do f of g of x. Likewise, f of h of x. Take a few minutes and solve for which one is the inverse function of f. If you are stuck with where to start, on the left-hand side, I did just how you would set it up, f of g of x. G of x is this whole fraction here. So we're replacing x in f of x with that green piece, x minus 2 all over 5. When I looked at that, I was like, ooh, we have a lot of work to do. I'm not sure if that actually is going to simplify. So I just took a step back, left some room. On the right-hand side, I did f of h of x. H of x is 5 over x plus 2. We were plugging that in for x in the bottom. Now this looks more like, ooh, the 2's are going to cancel. This one may be more promising than the left-hand side. So the 2's cancel here. So now I'm left with 5. Be careful, divided by 5 over x. So when I just said that out loud, that is the same thing as 5 divided by 5 over x. When you divide by a fraction, you multiply by the reciprocal. So that turns into 5 times x over 5, which then means this is over 1. Our 5's can cancel, and you are left with x over 1, which is x. So back to the original, f of x and h of x are inverses. If you were curious about the left-hand side, how you would even keep going with this one, because sometimes it might happen that, in fact, they are inverses, you would focus on the denominator and getting that to be one fraction. You would need to make this a fraction over 5. So 2 is technically 10 over 5, so you would have x minus 2 over 5 minus a 10 over 5. So your whole denominator would be x minus 2 minus 10, so minus 12 all over 5. And then you would do the same thing, 5 divided by that whole fraction, which you can see this, we're just going down into a pathway that does not result in x being the answer. So looking at the right here, our goal was to get x in the composition, and that proved that f and h are inverses of each other. All right, next one. Please hit pause and write down every step of this This is when you are given a function and they are asking you to find the inverse function. Last class we saw it was very easy when it was only one operation. If I had x plus 4, we know the inverse operation of addition is subtraction, so then the inverse function would be x minus 4. Similarly, if we had 3 times x, inverse function of multiplication is division, so then x divided by 3 would be the inverse. Here, we're showing our steps of solving for the inverse function and finding what it is when we're only given one of them. So take a minute, hit pause, and write this down. All right, quickly, how I remember it. Check to see if it's 1 to 1, replace f of x with y, exchange x and y's role, and then solve for y. And I need to get my charger. All right, I'm back fully charged here. And let's see this one. So let's not do that one. Let's start simple here. Let's say f of x equals 5x minus 6. Let's go through the steps. So step 1, check to see if it's 1 to 1. This function is a line, so it is 1 to 1. So 1 to 1, that's the symbol I use. Check, it is 1 to 1. Step 2, change f of x to be y. Step 3, exchange x and y spots. Step 4, solve this new equation for that y. So multiplication and subtraction, undo order of operations backwards. So we have x plus 6 equals 5x. Divide both sides by 5. Y equals x plus 6 over 5. You can rewrite that with y on the left. And the last step is change y to be f inverse of x. I don't mind if you leave the function this way. You may also see the inverse function, since this is a line, both of these over 5, so 1/5 x plus 6/5. I don't mind if you leave your answer like this. But that would be the inverse function. If you ever have time left over, you can always go back and do composition functions to get x as your answer. All right, now let's try this one. We're finding the inverse of this function. So this is a line. It doesn't look like a line, but this is a line with 2 as the denominator. So it is 1 to 1. So now change f of x to be y. Next step, what would the next step be? If you said replace x and y, you are correct. So x equals 5 minus 3y over 2. Why do we change x and y spots? It's because the inverse function is a function that's taking the output as the input and getting out the input as its answer. Solving this, we need to get rid of the 2, so multiply both sides by 2, so we get 2x equals the numerator. Solving this for y, move 5 over, divide by a -3. Whenever you have a denominator with a negative number, it's best to take that negative and distribute it up to the top. So that will be -2x plus 5 over 3. It just looks nicer. Equals y. We're going to rewrite y as the inverse of x. And this is our final answer. All right, checkpoint here. Find the inverse function of f of x when f of x is 2x minus 3. Take a few moments and solve for the inverse. Look back at the steps that we took, or look back in your notes for the steps of finding an inverse. Okay, so your inverse function is x plus 3 over 2. Take a minute and check over my steps here. I am human and make mistakes. I'm pretty sure this one is good though. All right, now let's take a look at this one. Now we have the square root function. So we're going to find the inverse of f of x. So our f of x equals the square root of 2x minus 3. Rewrite f of x as y. Replace x and y. The inverse operation of the square root function, in order to get rid of the square root, is squaring both sides. Put parentheses around it because sometimes the left-hand side might be more than one term. So now we have x squared equals 2y 3. Add 3 to both sides. Divide by 2. So y equals x squared plus 3 over 2, or the inverse of f is x squared plus 3 over 2. If you need to look at it this way, 1/2 x squared plus 3/2, that also works. What type of function is this one right here? X squared, 1/2 x squared plus 3/2. If you said a quadratic, you are correct. However, last class we were talking about how quadratics don't have inverses because they are not one-to-one. So who remembers when I talked about the domain and range of the original function and the domain and range of an inverse? How do they relate to each other? The domain of the original, the domain and range of the original, and the domain and range of the inverse. How do they relate to each other? If you remember, I said the domain of the original is the range of the inverse, and the range of the original is the domain. They swap. So use that to our advantage here. This one here, f of x, the domain. We have domain restrictions. We cannot take the square root of a negative. So in this case, our domain is going to be the values of x that make this greater than or equal to 0. So x has to be greater than or equal to 3/2. The range, the smallest thing the square root function can be is 0, and there's nothing being added or subtracted, and there is no reflections. There's no negative out here, and there's no negative in front of the x. So our range are y's greater than or equal to 0. Why does this matter? The reason for this is when we get down to our inverse function, we have to restrict it because right now we have that the inverse is this entire thing. We can only take half of it. We have to focus on the domain and range from the original and swap them. So the domain of the original is going to be the range. So that means y greater than or equal to 3/2. Notice I changed the x up here to y. And the domain, x has to be greater than or equal to 0. This one here is the most important one. When you have an inverse of a square root function, you have to restrict the domain and say you're only taking half of it. And by doing so, you find these by doing the domain and range of the original. So this here would be the final answer. Do you need the range part? No, I just put that in there just because we have already found the range of the inverse from finding the domain of the original. All right, so finding the inverse function of f of x is x squared. If this part wasn't there, we would say not one-to-one, not an inverse. However, looking at this graph, x squared, when x is greater than or equal to 0, we're only taking this half. So that is one-to-one. So go through the steps here. F of x is x squared. Rewrite as y. Exchange. When you take the square root of both sides, usually you do plus or minus. You're only doing plus because you only half because you want the reflection of your graph and you're only taking half. So y is going to be the positive square root of x. This one, the domain and range are both greater than or equal to 0, and that is what the domain and range of the original are. When they're the same, when you swap them, nothing changes. So our inverse would be the square root of x. Let me know if you have any questions. Thanks, guys.